In this segment, we're going to examine a few ways to evaluate the energy consumption of different electrical devices and develop an energy audit. First, we're going to start by using appliance labels, then use other methods to determine power and energy consumption using empirical measurements, then look at online resources, an electrical utility bill, and how to conduct an energy audit of electrical devices. Nearly all electrical devices in the United States come with a label or a tag that indicates the amount of power the device consumes or the voltage and the current required to power the device. If the device power is listed on the label, we can calculate the energy by simply multiplying the power of the device by the number of hours the device is in use. So, for example, a 60-watt light bulb that's used for 5 hours per day would use 300 watt-hours per day. And if it's used by 365 days per year, it would consume 109,500 watt-hours per year, or 109.5 kilowatt-hours per year. Separately, if a light bulb indicated that it used 0.5 amps while operating at 120 volts, we would then calculate that it consumes 60 watts when in use. We can then multiply the power by the hours in use and again derive the energy consumption per day or per year. Depending on what type of label is shown on a device, you'll have to perform one of these two calculations. Let's now look at this in real time. In this example, I've plugged in my light bulb into a watt meter, which shows the system voltage is approximately 120 volts, but since it's off, there is no current, or 0 amps. Once I turn on the light bulb, the current measures 0.509 amps. It also tells me that the wattage of the system is 67.7 watts, which is close to the calculated value within error. I can then use the same meter to compare 3 different light bulbs: an incandescent, a compact fluorescent, and an LED. And we can see that for almost the same equivalent brightness, the incandescent bulb uses 67 watts, the compact fluorescent uses 19.5 watts, and the LED uses 8.5 watts. This also illustrates how switching to more efficient devices can reduce the overall energy consumption. A coffee maker is a typically high-powered device, and the label indicates that it consumes 7.5 amps when in use, plugged into our watt meter. So we can see that the background power is about 0.5 watts, but as soon as we turn on the power, it goes up to 873 watts. 120 volt operating system voltage times 7.5 amperes equals 900 watts. So the coffee pot is operating near its maximum rating. Similarly, a microwave, which is rated at 13 amps, has some background power of about 1.5 watts, and then goes much higher to 1,691 watts when in use. Finally, a refrigerator is a bit more tricky because while there's an amperage rating on the refrigerator, it cycles on and off with the compressor, as well as when the light goes on and off with the door open. So it goes very low when the light is off, and then it goes slightly higher when the incandescent light bulb turns on and the door is open, to 94.5 watts. The power then goes much higher to 880 watts at the peak power with the compressor running. So the power consumption is very variable. In this case, an instantaneous power measurement like we did before is not very informative because consumption fluctuates so much. In situations like these, finding published annual energy consumption data from the manufacturer or a third-party site like Energy Star would be more accurate. We'll look at how to do this in an upcoming segment.